Often we don't notice it's even there, but it's all around us. It's in our environment, it's in our water, it's in our homes, our streets, and our food. It is at the center of new technology, new forms of energy, new ways to fight disease, and new ways to solve the problems we all face together. It is every day, and it is life changing. It is the future. Often we don't notice it's even there, but it's all around us. It's in our environment, it's in our water, it's in our homes, our streets, and our food. It is at the center of new technology, new forms of energy, new ways to fight disease, and new ways to solve the problems we all face together. It is every day, and it is life changing. It is the future.
Hello. Uh, Good evening, everyone. Shall we start? Right. The session mainly talks about atomic structure tutorial number 10. This tutorial, and we'll try to this like just to revise the material and then revise and remind you some of those things that is there. Right. Okay. Good evening, everyone. Right. Okay. So I hope you can hear me well. And let's start with this. So in this tutorial, these tutorials are like some of the questions from various types of provincial papers, right? From the unit number 1. And they comprise some of the papers given in Colombo schools and some of the schools in Kandy, right? So like just to see whether you are up to that level, like, whether you can answer this, right? Okay, let's start with this. First question is, first one, like I have given you some space also if you want to write certain aspects regarding the discussion, right? If there are certain things that you want to write down, you can write it there itself and keep it as a kind of a proper record, right? So that's why the space is given. Which is not a property of cathode rays. First one. So first one, if you look at it, they are attracted to the positive plate when an electric field is applied along their path. Yes, that's true. No? Cathode rays are negatively charged, so they are attracted to the positive plate. So I think that is a true statement. The E divide by M ratio cathode rays from different gases is a constant. Second one, you know E divide by M ratio is a constant because these are all electrons. From all the species, the electrons, their mass and their charge are both the same. So therefore, that is also a constant, right? I think that is also right. Next one, there is an inclination towards the north pole in the magnetic field. Third one, what do you think? What is your thought? You need to tell me, right? What is your thought? Now, that is a false thing, right? That is wrong because inclination means it gets attracted towards the North Pole. No. What is the actual rule? Actual rule is they get deflected according to the Fleming's left-hand rule. Yes, Fleming's left-hand rule. So, Fleming's left-hand rule. So, I'll write that. Fleming's left-hand rule. Left hand rule. So that is wrong. So you can say in your text, when you're writing that, you can say they are deflected according to the Fleming's left-hand rule. That's what we need to write down. They move in straight lines. Yes, they move in straight lines. Not always. It doesn't say always. They move in straight lines. Yeah. And the nature of the cathode rays not depend on the gas inside the cathode ray tube. So fourth one is right. Uh, gas inside the cathode ray tube or the material that is used for it. That is also a kind of a true statement. So answer that we will settle for is the third answer. I hope you got the idea there, right? That is the first question. Let's look at the second question, right? Okay, right. Now, I might say wrong things also. You have to be very careful and you need to correct me, right? If I'm wrong, right? So next one, who showed the charge to mass ratio of the cathode ray particles does not vary with the gas obtained in the cathode ray tube? Who showed this? Who showed this? Right? Who showed this? Right? Can you tell me who showed this? Right? You need to say that it is J.J. Thomson, right? J.J. Thomson. Yes. J.J. Thomson, right? Thomson is the one who showed this. And then Thomson, right? S-O-N. And then, what did he use? He used the electric field and magnetic field together. And then he calculated the C divide by M ratio. And for various materials, he got that as a constant thing. So answer is just 3. Okay. If there are anything else, right? G.J. Stoney predicted the presence of an electron. Ernest Rutherford discovered the proton, discovered many things, nucleus and all that. R.A. Millikan determined the charge of the electron. William Crookes is the first person to detect a beam of cathode rays. First person to detect it. Right. Third one. Who among the following is a scientist who gave the name to the electron? Who gave the name to the electron? Right? Okay. Now, very quickly, tell me what is your answer. Who gave the name to the electron? Electron's name was first given by G.J. Stoney. Third answer, G.J. Stoney. Third answer, he used Humphrey Davy's ideas. He used Michael Faraday's ideas, and when he looked at this work, he thought that there should be a negatively charged particle. That negatively charged particle was not discovered at that time, but he said that if one day a negative charged particle is discovered, it is named as the electron. So whose work? Humphrey Davy's work. And who else? Faraday's work. Right, very good. Fourth one, the scientist who named the basic unit of electricity as electron. Basic unit of electricity as electron, right? Tell me the answer. Yes, again the same thing, stony. Stoney, stony, right? All again the Humphrey Davis work and Michael Faraday's work. Fourth answer. Not fourth answer, third answer, right? Third answer. Everything is third. Now, I'm little surprised with that. Fifth one, think about next one. Who observed the study of cathode rays? I'm just looking at some of the answers that you provide as well. Who observed in the study of cathode rays that the nature of cathode rays does not change regardless of the material of the cathode is made or the gas in the tube? So here also the answer is second answer, J. Thomson. J, I will write say T, so second answer, right? Here it is the third answer, right? Yeah, right. Okay. So I hope you got the idea there, right? Okay. Sixth question. See whether we can do this, right? Which of the following statements is true? Which of the following statements is true? In an electric field, cathode rays are deflected perpendicular to the field. In an electric field, cathode rays are deflected perpendicular to the field. We'll think about it, right? We'll think about it. If there is an electric field like this, and if the cathode ray travels, right, you have a positive charge and negative charge. This is your electric field, right? And then this is the negative charge particle. It deflects towards that direction. But we'll see, right? Let us read the other ones as well. So first question, first answer, we have a little bit of a question. Second one, a cathode ray is a beam of particles with both mass and the kinetic energy. What do you think? Second answer looks like correct. It looks like right because cathode ray is a beam of particle with both mass and kinetic energy. There's a particle and it has a velocity. Because of that, you have energy. Kinetic energy is equal to, what is that? Half mv squared. There's a velocity, there's a mass, so it has some energy. The nature of the cathode rays does not vary with the gas in the discharge tube, but with the material used in the cathode. I think that is wrong. It doesn't depend on the material used in the cathode also, right? Fourth one, cathode rays are not deflected in a magnetic field. That is also wrong. Why wrong? Because they are deflected, right? And the last one, the E divided by M ratio cathode rays from different gases is different from each other. We are talking about cathode rays. No, they are not different. So fifth one is also wrong. So let us say perpendicular, which is not always perpendicular, right? Let us say there's an electric field this direction and the cathode ray enters that way and it is going in that direction as well. So I will take this as wrong and therefore second answer. Do you have any disagreement with that? Second statement is the answer I would choose, but if you have any arguments with that, I'm open for those arguments. You should argue, right? As a scientist, you should argue, right? Don't listen to me and say, okay, that is right. You should always consistently make a kind of at least a mental argument with me. Right? It travels along the direction and yeah, it depends on how the electric field is applied, isn't it? Not always perpendicular, right? It depends on how the electric field is applied. Okay, right. Question number 7. Shall we go to question number 7? Okay, right. Which of the following statements is true about cathode rays? Which is true about cathode rays? Attracted towards the north pole in a magnetic field. It is never attracted towards the north pole, no? So that is one is wrong. Huh? Second one, attracted towards the south pole of the magnetic field. I think that is right. No? South pole, that is okay. And then the south pole, it's getting attracted, right? What do you think? You agree? South pole getting attracted. No, it doesn't get attracted to that, right? Okay, so that is also wrong. Contains helium nuclei. which contains helium nuclei. Which compound contains helium nuclei? What is the compound that contains helium nuclei? Does it have helium nuclei? No, alpha particles contain helium nuclei, not the cathode rays. Third one is also wrong. Moves in a straight line. Now, moves in a straight line, it is true, but does it say always? It doesn't say. It's not always moving in a straight line. So it moves in a straight line, that is true. But we'll look at the other one, able to perform work while traveling. I think that is the best answer, right? So I will take it wrong. And fifth one is, in these ones, you select the best answer. So this is the best answer, right? In a magnetic field, it doesn't move all, but then it's also always saying it doesn't say always, but able to perform work while traveling. I think that is a better answer. So we will settle for the fifth answer um, from this one. These are all school papers, some past paper questions from school papers, right? So you can, whenever you do the first term exam, you'll be able to go through some of these things, right? The term electron was first introduced by, we have gone through that earlier, Stoney, the fourth answer, right? Fourth answer, right? Go to question number 9, right? Let's look at question number 9. Okay, so this one, it says, does the attraction happen depending on the Fleming's left-hand rule? For what? Fleming's left-hand rule happens for magnetic field, right? In the presence of a magnetic field, right? Okay. Okay. Why can't we say travel straight? Okay, so let us say you have a electric field here, right? Somebody asked this question, so I will erase this one. Let us say you have a positive charge here, negative charge here, and the alpha particle or the cathode ray travels in that direction. Does it travel in a straight line? It is not going to travel in a straight line. So it is going to travel in a, what kind of a line? What is the line that it will travel? Right? It will travel in this kind of a pathway. It's a curved pathway that will travel. So you can't always say that it travels in a straight line. Did you understand that? But then compared to that, I think better answer is the other one, right? Is it clear? Yeah. Okay, question, right? Do you agree with that? Yeah. Yes, very good. Right. Okay. If you're okay with that, please explain the meaning of able to work while traveling, because it has a momentum. So it can hit on something and it can start rotating like how it did the paddle wheel, right? How it did the paddle wheel. Is it clear? Right. Okay. Right. Question number 9. Question number 9. Let's start doing that. The two scientists who discovered the radioactivity caused by nuclei of certain elements and the generation of positive rays in the cathode ray tube was respectively. Scientist who discovered radioactivity was Henry Becquerel, isn't it? Henry Becquerel. Yeah, right. And then Henry Becquerel, and then generation of positive rays in the cathode ray tube was, who was that? Eugene Goldstein. Eugene Goldstein. I think third answer, isn't it? Question number 9, third answer is the right answer. Everybody okay with that? Right. Okay. Question number 10. Read the question and tell me whether this is okay. Question number 10, Puta, right? Consider the statements 1 and 2 given below. Presenting the golf ball model as an atomic model. Who did that? Golf ball model. John Dalton, yes. Providing the experimental proof of existence of positive charges in matter. Who provided that there is a positive charge in matter? I think that is Eugene Goldstein. He is the first person to identify the presence of positive charges in matter. So is their answer John Dalton and Eugene Goldstein? I think third answer is the right answer, right? If there are any doubts, you need to ask that, right? You need to ask that. Don't keep them to yourself, right? Question number 10. You can say John Dalton. Dalton's atomic theory you can write down, right? Here in this, like just to remind. Of course, they don't ask what are the things in the John Dalton's atomic theory. All atoms are made out of small indivisible particles called atoms. All matter is made out of, right? The matter cannot be created nor destroyed, right? And then what is the next one? All the atoms in a single element is the same. Two different elements have two different, by mass and by shape, they are different. Whenever chemicals combine to form compounds, they do so in simple whole number ratios. These are the 4 points of the John Dalton's atomic theory. I hope you can understand that, right? Then let us go to question number 11. See whether you can come up with an answer to this. Tell me whether you can come up with an answer. Who of the following scientists show that the charge to mass ratio of positive ray particles, be very careful, positive ray particles, charge to mass ratio, right? Correct it, no end there. Ratio of the positive ray particles vary with the gas contained in the cathode ray tube. Who did that? Right? Be very careful. No. Right? Goldstein is the one who discovered, right? Goldstein is the one who discovered this, right? And then who else? Next one is, a lot of people think it is Rutherford. Yes, did you understand that? Yeah. But then you have to remember J.J. Thomson is also, yes, say J.J. Thomson is also contributed to calculating this E divide by M ratio. So Goldstein, actually J.J. Thomson is the one who determined the E divide by M ratio of protons, not protons, positive charges. And then he collaborated with Rutherford. And then Rutherford is the one who gave the name proton. So J.J. Thomson is the one who determined the E divide by M ratio of electrons as well as protons, because he knew the method, right? He knew the method. So this is E divide by M ratio, nothing else. R.A. Millikan determined the charge of the electron, right? Stoney named the thing. Rutherford named, Stoney named the electron, right? R.A. Millikan determined the charge of the electron. J.J. Thomson determined E divide by M ratio of electrons as well as protons. Is it clear? Right? E divide by M ratio discovered by, he determined this as well. Protons also, right? So that you have to mark. That is a kind of a usual mistake that people make, right? So J.J. Thomson is the one. So this is the third answer, right? Third answer. Okay. Then question number 12. Question number 12. The mass of the proton is given by, they have given as grams. Can you tell me mass? What is the mass of the proton? 1.673 10 to the power minus 27 kilograms. Can you tell me what is it in grams then? Grams. What is it in grams? 10 to the power minus 24 grams. So it's direct answer. 10 to the power minus 22, 25, 13, 8, 10 to the power minus 24 grams. Fifth answer is the right answer. Clear? Question number 12. Question number 13. Right? Check whether this is okay. Right? It's getting harder now, right? You have to kind of focus it. Right? Right? Who found the proton? Rutherford or Goldstein? Rutherford is the one who found the proton. Right? Goldstein discovered the positive charges, but didn't discover the proton. E divided by M ratio of positive charges were calculated by Thomson. And Rutherford, using this data, all this data, he gave the like the particle that is generated from hydrogen, the name proton. Right? Okay. Question number 13. Right. See whether this is okay. Which of the following statements about alpha, beta, and gamma rays is false? Which statement is false? Right. False. The wrong one, right? Gamma rays are not accelerated in an electric field. What can you say? Gamma rays are not accelerated in an electric field. What is your thought? Yeah. Yes, it is false. Now, can you tell me why? Why? Gamma rays are not accelerated. Yeah, true. Why? What is the reason? I said false. No, true. It's a true statement. One is true. It's a true statement. Can you tell me why? Because it doesn't carry a charge. Yes, no charge in it. No charge. So therefore, no external force. No external force. Gamma rays anyway travel in the speed of light, isn't it? Right. Very good. Very good. Alpha particles are positively charged. What do you think? Second one, what do you think? Is it a true statement or a false statement? Alpha particles are positively charged. I think that is also a true statement, right? So that's a true statement. Okay. I think you agree with that, right? Okay. Next one, alpha rays show more acceleration than the beta rays in an electric field. Alpha shows more acceleration. Shows greater acceleration. Is it true or false? Greater acceleration. True or false? What do you think? Beta particles or alpha particles show great acceleration? Right? Okay. So now we have a little bit of a problem. So it all depends on the charge and the mass. Charge and the mass. So charge and the mass means that also depends on the E divided by M ratio. Right? E of this is the charge of the alpha particles plus 4. What is the mass? Mass is 4. 4 units. So the unit is like, E divided by M ratio is roughly around 1. I'm just taking the relative values. Relative charge, relative mass. That is for the alpha particles. Now, why did we consider mass to be 4? What is the reason to consider mass to be 4? Mass is, charge is plus 2. Yeah? Charge is plus 2. Sorry. I made a mistake there. Charge is plus 2. Charge is plus 2 and the mass is this. This is 0.5. Is it clear? Right. Now, E divided by M ratio of a beta particle. Charge is -1. The mass is very small. Mass is very small. Did you understand that? So now if you look at this particle, it has a very, very high E divided by M ratio. Large E divided by M ratio. So who can be accelerated easily? The beta particle or the alpha particle? Who can be accelerated easily? Who can be accelerated easily? Yes, you can see beta particle can be accelerated very easily. So beta can be accelerated because its E divided by M ratio is very high. Can be accelerated better. Easily accelerated. Now, what do they say? Alpha particles show more acceleration than the beta particles in an electric field. I think that is a wrong statement, right? So I feel like that is wrong. But let us look at the other ones as well. Fourth one. Ernest Rutherford discovered that the radioactive elements release alpha, beta, gamma radiation. What do you think? Ernest Rutherford discovered alpha, beta, gamma radiation. What do you think? Is it a true statement or a false statement? Who discovered alpha, beta, gamma radiation? Huh? Who discovered alpha, beta, gamma radiation? Discovered by Rutherford. Nobody else. Rutherford is the one who actually first to filter is named as alpha, second to filter was named as beta, and third to filter is named as gamma. So I think that is a true statement. Alpha rays are a type of high energy radiation. What do you think? Yeah, so that's a true statement as well. The answer is 3. Did you understand that? Somebody has said, can you explain this acceleration a little bit? Now, acceleration means, Puta, this. You have a particle and you allow this to move ahead, move faster, like you are accelerating a car, vehicle. So it depends on 2 parameters. Smaller the particle, you can accelerate it better. And greater the charge, also you can accelerate it better. Because if the charge is high, it's attracted very quickly. If the particle is small, you can accelerate it better. Imagine that you have a tennis ball and a putt shot, right? You can't accelerate the heavy putt shot, but the tennis ball you can accelerate easily. Did you understand that? So, only problem is in this alpha particle and the beta particle, they go in opposite directions. Alpha particles have a higher charge, beta particles has a lower weight. So which has a better effect? It depends on E divided by M. It depends on this E divided by M ratio. Right? So if you look at E divided by M ratio, Puta, E is +2, isn't it? Why? Because it is alpha particle. M is 4. So value is 0.5. I hope you got that. Is it clear? Yeah, right. And then if you look at the beta particle, what is the charge? Charge is M and charge is -1 and the mass is simple M. It has a very, very low value, 9.108 10 to the power minus 31 kilograms, right? Very, very tiny. So you are dividing -1 with a very small weight and you get a large value. If it is having a large value, that means you can accelerate it better. So beta particles can be accelerated better. Did you understand that? Is it clear? Did you understand that? Yeah. Everybody okay with that? Okay. Now somebody asks here, Henry Becquerel is the one who discovered radioactivity. Oh, absolutely right. Henry Becquerel discovered radioactivity, but alpha, beta, gamma radiation was discovered by Rutherford. Right? So what they ask is alpha, beta, gamma radiation. The emission of some unknown particles spontaneously with very stable, very unstable elements is called radioactivity. That was discovered by, no doubt with that, that was discovered by Henry Becquerel. Is it clear? That was discovered by Henry Becquerel, true. But alpha beta particles, alpha beta gamma particles was discovered by Rutherford. Yeah. Same question, if Becquerel discovered radioactivity, how come Rutherford discovered alpha, beta, gamma particle? Becquerel discovered radioactivity by accidental discovery. So it's an accidental discovery. It means that there is some highly penetrating rays are emitted. But he didn't know what are emitted. Rutherford is the one who discovered alpha, beta, gamma particles, gamma radiation. So that is how it worked. Everybody okay with that? Yeah. I'm just looking at your answers, right? So Ernest Rutherford discovered the radioactive elements released, alpha, beta, gamma radiation. That's a true statement, huh? Right? Those true statement, right? Right. Okay. Very good. Well done. Good. But the minus value is comparably less than the positive, right? No. There's nothing, it's like, I think I talked about this. Minus is not less than plus. That is in mathematics, right? Minus is a different type of charge. Positive is a different type of charge. Okay, it's like I gave you this example. It's like, like somebody says males are better than females. It's nothing to do with whether they are males or females. It's definitely do with how hard they can work and how can they meet challenges and face life. That's how it works. So it's just like that. There's nothing called this one. Then Marie Curie didn't find radioactive elements. Of course, she found radioactive elements. But the first discovery of radioactivity was discovered by Becquerel. There were a few things I gave them very neatly. First one is Henry Becquerel is the one who discovered radioactivity. Marie Curie worked with this and she discovered different elements, polonium, thorium, and radium. And then she gave a sample of polonium to Rutherford. Rutherford came back to England, Cambridge, and he was working on this, and he discovered that there are three types of radiation that is emitted. Two types of particles, alpha, he named alpha. Then the next one is beta, and the other radiation is called the gamma. That's all. That's the story behind it. Right? Okay. So need to look at those again. That's why I'm doing this tutorial also, just to get rid of some of those confusions. Right. So what is the answer? You agree with that? 3. Third answer is the right answer. It says alpha rays show more acceleration than the beta rays in an electric field. That's a wrong answer. Everybody okay with that? I hope I answered your problems as well, right? Is it clear, children? Everybody okay? All of you? Right. Okay. Let's try the next one. Question number 14. Let's look at this. Right. Good. Good. Question number 14. Let's get a pen. Right. Question number 14. Tell me what is your answer there. Right. So that is something. That is why you there's some space there. You can write it down and make sure that you complete the answer today. Right. Today itself. Don't wait for another one. Right. Okay. Right. Is it clear? Everybody understood that? Right. Okay. Question number 14. Who first represent a model of the nucleus of the atom? Can you tell me what is your thought? Who first represent a model of the atom? First ever nuclear model was put forward by none other than Rutherford. What is his famous experiment? What is his famous experiment? 14.4. What is the famous experiment? Right? He did this gold foil experiment. Gold foil experiment. You can write it down. Gold foil experiment. And he proved that there is a positive charge nucleus. Positive charge nucleus. Concentrated into a very tiny volume. Right? And then he measured the radius also. Can you tell me what is the radius of the nucleus? Right? We discussed that. Right? What is the radius of the nucleus? 10 to the power minus what? We did a calculation also. Right? Every little detail we did. Now 10 to the power minus 8. 10 to the power minus 8 is the radius of the atom. 10 to the power minus 13. Yes, 13 centimeters. 10 to the power minus 13 centimeters. Now 10 to the power minus 8 is the radius of the atom. 10 to the power minus 13. We did a calculation also. We did the calculation of the fraction of volume. Right? Right. So, okay. Now you understand. 10 to the power minus 13 centimeters. Now remember, whenever you put a number, you need to give the unit also. Without a unit, it doesn't mean anything. It can be 10 to the power minus 13 meters. We don't know, right? So that is what you have. So answer represent a model, Ernest Rutherford. Ernest Rutherford. It's a nuclear model. Now, it's not the golf ball model. First atomic model is the golf ball model, but it doesn't have a nucleus. This guy, Rutherford, is the first person to say that there is a nucleus in that. Did you understand that? Everybody? All right. Question number 14. Tell me, did you do you have any questions, Puta? Any questions? Anything that you want to ask? Anything, right? Whether you want to ask anything there, we can look at that immediately. Right. Answer number 4, question number 14. Question number 15, try that. Question number 15. Right, okay. Read that, and give me the best answer, right? Okay. Consider the following hypothesis discoveries related to the atomic structure. Like planets orbiting around the sun, atomic nucleus is surrounded by electrons orbiting around it. So one of the people who said that for the first time is Rutherford. Rutherford is the first time to say this, right? First time to say this. Okay, Rutherford is the first time to say this. And then, but then if I look at these answers, I don't see Rutherford, but I can see Bohr is there. James Chadwick didn't say anything about that. So I'm going to read the other one as well. The number of positive charges in the nucleus increases 1 electron unit at a time. Right? Number of electrons, number of positive charges in the nucleus. Who discovered the number of protons in the nucleus using X-ray diffraction data? Can you tell me who discovered this? What is your answer to this one? Which answer is that? Who discovered the number of protons? Yes, number of protons in an atom using X-ray diffraction data. Mostly, yes, mostly. So Niels Bohr and mostly are the answers. Second answer. So you can write it down under that. You can write it down. So what Niels Bohr said was, these are electrons are like planets around the sun in different energy levels. Different energy levels. That was something that Rutherford put forward. He was inspired by Rutherford's work. Right? But only thing is, Rutherford said that they have equal distances. But he said this, Bohr said that they are in different energy levels. And then mostly is the one who discovered a method to count the number of protons in a nucleus. And he understood that they increase in 1 unit at a time, right? So the other one is mostly. So I think answer number 2. Any different answers, anything that you can't remember, you can't understand? Yes, okay. Many of you agree with the second answer. Yes, well done. Right, okay, yeah. If he had the answer as a Rutherford and mostly, then it is also correct. But then Bohr also said the same thing, right? Yeah. Can you repeat the mostly's part? Mostly is the one who discovered the number of protons. Number of protons in a nucleus using X-rays. So when you look at this in the periodic table, you can see that they are increased 1 unit per time. Question number 16, what is your thought? It's an immediate answer, right? It's an immediate answer, straight away, direct answer there. What is your answer there? Can somebody tell me? Neutron was discovered by who? Who discovered the neutron? Right? Mostly, no. Mostly is for the early answer. Now, I want the name, not the numbers. Don't give me the numbers. Because when you say the name, you remember it. Like numbers doesn't mean anything. So you need to tell me the name. Name. What is the name? Neutron was discovered by James Chadwick. Can you tell me his experiment? James Chadwick. Chadwick experiment is like number 2. This is number 2. What is his experiment? His experiment was an alpha ray bombardment experiment on a beryllium foil or a boron foil. Remember, very good. Beryllium sheet or a boron sheet. Alpha particles being bombarded. Right, James Chadwick. Yeah, I'm just looking at your answers as well. Right, okay. Beryllium foil or a boron foil also. Right, remember, neutrons was emitted. Right, neutrons was emitted. When neutrons are emitted, he had this alpha particles. Right, there's a radioactive material which emits alpha particles, and you hit this on a beryllium foil. Beryllium foil. When he hit on the beryllium foil, he got neutrons emitted. 0, 1, 0. This kind of neutron was emitted. So that is what he looked at. Chadwick, right? So this is the second answer. Okay, go to question number 16, 17. Question number 17 says, what does it say? The electron was discovered by, who discovered the electron? If you know it very quickly, tell me. Who discovered the electron? Give me an answer very quickly. J.J. Thomson. Yes, J.J. Thomson. You know that J.J.T. So first answer is the right answer. Question number 18. Right? The proton was discovered by, who discovered the proton? Ernest Rutherford. Yes, right? Lord Ernest Rutherford. So second answer, right? Now these are direct answers. Question number 19. Let's see. Don't get bored, right? Pay attention, right? Consider the following findings related to the atomic structure. Right. Now, very quickly, give me the answer immediately. Don't tell me which answer is that, but I want the name to be written. Conducting experiments to find isotopes. Who did that? Who did that? Yes. Who did that? Yes, I can see one answer, one correct answer. Yes, very good. You are right, Pudha. You are right. Okay, yes. Who did the experiments to find isotopes? F.W. Aston. Aston is the one who did the experiments. What is his experiment? It's a mass spectrometry experiment, Aston. Determining the E divided by M ratio. E divided by M ratio is who? None other than J.J. Thomson, right? J.J.T. Okay, right? Tell me your answers also, right? And then discovery of the nucleus of an atom. Who discovered the nucleus of an atom? Ernest Rutherford. Yeah, very good, very good. Ernest Rutherford. So your answer is Henry Becquerel. No, first answer is wrong. Let us look at the second answer. That is also wrong. Third answer, that's right. Aston, Thomson, and Becquerel. No, fourth answer is the right answer. You got that? Very good. Did you understand that? Wow. Well done. Good, Good, very good. Right, okay. Question number 20. Question number 20, tell me what is your answer there, right? Question number 20. Okay. So immediately, you write these answers as soon as I tell you, you send the message. Consider the statement 1 and 2 below, introducing the name electron for the elementary particle of electricity. Right. So that is, who did that? Who did that? It's Stoney, right? First one is Stoney. Finding the electron's charge to be 1.602 10 to the power minus 19. Now, tell me your answer. Right? Who did that? Who did this finding the electron? Charge of the electron? Yes? Okay, well done. Who is that? Charge of the electron was discovered by, calculated by Millikan, right? What is his experiment name called? Millikan. What is his name? What I mean, his name is Millikan, of course. What is the name of the experiment? Can you suggest the name of the experiment, Pudha? What is the name of the experiment? Yeah, his famous oil drop experiment. Oil drop experiment. So you can use oil drop experiment. I just write and leave it there. So oil drop experiment. What is your answer? Stoney and Millikan. Second answer. Agree with that? All of you? Wow, good. Well done. Very good. I'm just looking at your answers. I have some, several hundred messages. How did Moseley find out using X-ray diffraction data? Right. Good. Well done. Yeah, right. So keep on working, right? Because A level is not a easy one. I want you to work from the day one itself. Complete these things and you will be very happy at the end. Right? Okay. Right. So done. 21. We'll go to the next one. Question number 21. Tell me what is your thought on this. Which of the following sets of numbers represent the number of protons? Number of protons, number of neutrons, and number of electrons. In O2, 2 minus, this is 18 and 8. Okay, so don't be in a hurry. Yeah? Listen to this very carefully. 8 is the number of protons in a single atom. So number of protons is 8 in a single atom. Right? Number of neutrons plus number of protons, how much is that? It is the mass number. What is the mass number here? Mass number is 18. So what is the number of neutrons here, Pudha? 18 minus 8. 18 minus 8 is 10. Number of neutrons is that. Usually, what is the number of electrons in a neutral atom? Can you tell me? What is the number of electrons in a neutral atom? What is the number of electrons in a neutral atom? In this case, if there are 8 protons, you have to have 8 electrons as well. So this is a single atom. Did you understand that? Do you have any problem there? Any problem there? Anybody who didn't understand this? Everyone okay? Yeah? Ah, right. Okay. So all of you okay with that? Right. Ah, yes. Okay, right. So now let us look at, now here it means there's 2 atoms connected together, 2 extra electrons, 2 extra electrons. That is what it means. It's a negative charge. Now here 2 atoms are there, 2 atoms. Then Pudha, can you tell me how many total number of protons are there? Number of protons. In one atom, now you have to bring the answers. In one atom, there is 8. 2 atoms, you have how many? 8 times 2, altogether 16. Everybody okay with that? Right? Come up with the answers. Right? Is it clear? Everybody okay with that? Ah, right, good. Then the next one is, that is number of protons, number of neutrons. What is the number of neutrons? You have 10. In 2 atoms, you have 20. Number of electrons, you have 16. But since there are 2 extra electrons, you need to add another 2 here and you get 18. So your protons would be 16. Are the neutrons would be 20 and electrons would be 18. 16, 20, 18 is your answer. 16, 20, 18 is your answer. What is that answer? The third answer. What is the third answer? Everybody okay with that, children? Don't we have to add 4? Why are we adding 4? What is the reason? Here, like, oh, this is the overall charge. Overall charge is 2. Overall charge is -2. If you add 4 electrons, it will be 4 minus. Yeah, right, okay. Okay, I hope you got the idea there. So answer is third answer, right? Okay, go to the next one. Question number 22. Read the question number 22. Tell me what is your thought on that. Now, very slowly do this, right? Okay. The number of electrons and neutrons in a triple positive ion of chromium 5224. 52 chromium 24 triple positive ion. Triple positive ion means Cr3 plus. Triple positive means that. Okay, now tell me how many electrons, how many protons are there? How many protons are there? Now everybody should answer, right? Don't give up. Don't give up, right? Well, how many protons? Protons 24 is equal to the charge number. 24 number of protons. So number of neutrons, how much? 52 minus 24. How much is that? 28. Yes, very good. 28. Right. What is the number of electrons? Normally, you have 24 electrons in an atom. But now what has happened? You have gotten rid of 3 electrons. So what is that? 24 minus 3 is equal to 21 electrons. Everybody got that, Pudha? And these are the values. Right. Right. Let's look at the answer. What do they ask? Number of electrons and neutrons. Electrons and 21 and neutrons are 28. 21 and 28 is the second answer. Is it clear, Pudha? I hope you all got these answers. Did you understand that? Everyone? Ah, right. Okay. Any part that you didn't understand? Right? Second answer, either. Right? Is it clear? Right. Okay. Good. Well done. Very good. I hope all of you got the idea. Yes. Right. Good. Right. Go to the next one. Question number 23. If there is any additional question, you need to ask. You need to post it. I will try to answer that. Right. Number of electrons, neutrons, protons in 85, 81. A. What is the other one? 35 minus. Right. What do they ask? Electrons, neutrons, and protons. Now, number of protons is equal to number of electrons usually, usually 35. But here, number of electrons are something excess than that. So, what is the number of electrons? There's a one additional electron. Can you tell me what is the number of electrons that is present in this sample? 35. What is the number of electrons present in this sample? Very quickly. 1 electron extra. 1 electron extra means you have 36. Very good. 36 electrons. And can you tell me how many neutrons are present? 81. Total 81 neutrons, protons present. Minus 35. How much is that? How much is that? 46. How much? 46. Yeah. 46. Right. Okay. So number of electrons, 36. Number of neutrons, 46. And number of protons is 35. Is there an answer? Which answer do you agree with? What is the answer that you agree with? What is the answer that you agree with? Which answer? Ah, yes, fifth answer, right? So this one is the fifth answer. Very good. Well done. Right. Okay. Right. Let us do another 2 questions and we'll stop, right? So since these are the last 2 questions, I want you to do it really well with lot of encouragement. Right. Now, these questions are like, you have these MCQs. like, sometimes students fear these questions. In A-levels, it becomes a little tough. You need to know it really well. That is why. There can be multiple answers also. So you write the first answer if the A and the B are right. Second answer if B, C is right. Third answer is C, D is right. Fourth answer when you have D and A are right, and any other combination is the fifth answer. Right. Cathode ray particles are negatively charged. What do you think? Is it right or wrong? We are looking at the right answer, right statement. Huh? Right. Is it true or false? What is your thought here? Cathode ray particles are negatively charged. Are they? Is the statement true or false? Now everybody must answer, right? Okay. So it's a true statement, right? So A, we put a tick. Now what do you think about the next one? Attracted to the north pole of the magnet, the N pole of the magnet. Attract to the north pole. That is true, right? What do you think? You agree? Huh? Is it a true statement? No, it doesn't attract to the North Pole. It is attracted or deflected in such a manner that the Fleming's rule explains it. It doesn't go and hit on the North Pole, right? So B is wrong, right? Fleming's left-hand rule. Go to the next one. Attract to the negative electrode of an external field, right? Cathode rays attract to the negative pole. What do you think? Negative pole? Cathode ray attracted to the negative pole. What do you think? Huh? Cathode rays attracted to the negative pole. What are your thoughts? That's a false statement, right? They will be repelled from the negative. These are like charges. They tend to repel. And the last one, move along a straight path. B. What do you think? Is it a true statement or a false statement? Right? Some of you might say false, some of you might say true, because it doesn't always travel in a straight pathway, but it doesn't say always. So it can travel in a straight path. It also can travel in a curved path if the right force is given. So can we take it as right? If for the moment we will take it as right, huh? Right? So, and you can write down, but not always. Not always. It doesn't travel in a straight path always. But for the moment, we will take it as right. So A and D are right. If it is A and D are right, what is your answer? A and D are right. What is your answer? I'm looking at some of those answers. Right, good. If A and D are right, what is the answer that you think? The fourth answer, right? Fourth answer. But in the space you can write down. Now remember, cathode rays or canal rays, they never get attracted onto the North Pole or the South Pole. They get deflected only, right? And it says cathode move along a straight path. You can say not always, but they can travel in straight lines also. I think there's a kind of a little bit of ambiguity of this question. I didn't change it. This is a question that is given in a certain school paper. I didn't change it. I didn't want to change it. There's ambiguity. You can have 4 also, like if you consider it as right. If you don't consider it as right, that is also correct. And then you have the answer 5. Right. Last question for today, question number 25, right? Question number 25. Tell me what is your answer there. Which of the following is a true statement about the factors on which charge to mass ratio of a cathode ray depends? Charge to mass, E divided by M ratio of cathode rays depend. It does not depend on the metal the cathode is made out of. True or false? Clean your chat and give me answers. Otherwise, it is difficult for me to look at this. Clean the chat, right? You can clean the chat. is a standard answer number of MCQ questions. Yes, it is the standard way of answering, right? Clean the chat and then tell me what's your new answer here. It does not depend on the metal of the cathode is made of. Does it depend on the metal? No, it doesn't depend on the metal. So it's a true statement. So it is, I will take it as A is as a true statement. If you don't agree, like say that, I don't agree. You have to be very brave on that, right? So, right. So just say, okay, I am not going to agree with this. This is wrong. Does not depend. Second one, does not depend on the gas in the discharge tube. What is your thought? Right? Can you tell me? Third one, B, does not depend on the gas in the discharge tube. That's a true statement, right? It doesn't depend on the gas, right? Depends on the potential gap applied across the discharge tube. Does it depend on the potential that is there? E divided by M ratio. We said E divided by M ratio for cathode rays is a constant. We did never talk about a potential, right? So that's a depends on the potential gap. That's a wrong statement. C is wrong. And D depends on the pressure of the gas discharge tube. That is also wrong. So what is your answer? A and B are right. What is your answer? What's your answer? Everybody, tell me your answer. Right? What's your answer there? It's 1. Answer number 1. Right. Okay. So question number 25 up to 25 and 26, the remaining ones, we will discuss this on this Saturday when we meet. I am going to discuss that part and finish it off so that we can go for hydrogen spectra. Are there any other questions that you want to ask? Anything that you want to ask before we wind up today? Right. So please finish this, right? Yes, true. A and B are the right answers. First answer, right? Please make sure to finish the tutorial and bring the answers there, right? That's a really important thing. Very important one, right? Okay. So, yeah, can we get the recording of this session? I think this session is somebody will go through this and then they cut certain things, cut in the sense whatever the introduction parts, they might cut it off and they might upload it tomorrow, right? Not today. You might not be able to get it today, but I will send this document right now. Right? And then you should be able to still work it out. Somebody asked, in 1 O2 minus, there are 10 electrons. Puta, not 1 O2 minus. It doesn't say 1 O2 minus. What I gave you is O2 2 minus. O2 2 minus is in entire O2, there are 2 electrons extra. Okay. So this is not 1 O2 minus, right? There's O2 2 minus. Overall iron has a charge of 2 minus. That is what you had. Did you understand that? Is it clear? Right? People ask that question. Who asked this question? Tell me whether you understood that. Right? We have classes now. Now you all we from August we start. We do classes on Saturday. Saturday. Starting from starting from 1 o'clock, right? I think I mentioned this earlier, right? Okay. So anything else to answer? Can you explain a bit about oil drop experiment? That is out of the syllabus. It's no point talking about it. So Millikan, he drip a droplet and he applied a potential. And whenever the droplet falls down, and he used X-rays to ionize it. Droplets falls down, like he changed the potential and he's tried to suspend it in midair and did some experiment. I think it is no point, yeah. Don't be nervous. Don't be nervous. I have given all the material that you need, every little detail in the note. Make sure to look at that material and keep on studying. That's a very important thing. Right? Everybody starts at the same point, but only very few people finish it. ඒක මතක තියාගන්න. Don't get yourself distracted. Saturdays. Normal classes are now this month Saturdays. Saturdays 1 to 5. Right. Okay. Okay, Buddha, I'm not going to keep you more. Right. Make sure to work really hard. Read the material. Complete the tutorial. Tutorial number 10 should be completed by this Saturday. හරිද? ඒකට මම ඒක I am not going to visit that tutorial again. You have to move on, right? හරි පුතා. Okay, good night. Thanks for joining. I will send the document. Right? Good night.